in relation to linear lines. So if two variables are directly proportional, that is, the rate of change is variable with respect to the other is constant. So the rate of change of one variable is with respect to the other is constant, which means as it increases on the y values, it'll also increase on the x values at the same rate. That's all that point means. Then the graph is a straight line passing through the origin. That means that we're starting at 0.00, and then we're going to increase from there. And the rule is of the form of y equals mx. And now you might be considering, why is it not y equals mx plus c? And well, technically it is plus c, but remember c is the y-intercept. And in this case, our y-intercept is at 0. And that has no bearing on the rest of the equation. So we can just write it as y equals mx, because c has no bearing, or no weighting to the difference, right? C is a constant of 0, and so it doesn't change the value of m or x. The gradient of the graph equals the rate of change of y with respect to x. So again, that just comes back to that first point with as y increases, x will also increase. And it's going to increase at the same rate, the same consistent rate across it. So the question here says, water is poured into an empty tank at a constant rate. It takes 3 hours to fill the tank with 6,000 litres. There's our question. What is the rate at which water is poured into the tank? Well, it says that it fills 6,000 litres over 3 hours. So we could say that it's filling at a rate of 2,000 litres per hour. So the rate of change is 2,000 litres per hour, simplest form of the context of the question. Then asks us to draw a graph of volume, V litres, versus time, T hours, using time as any number between 0 hours and 3 hours. That's that inequality spectrum there, that T could be any value between 0 and 3. So then our axes, let's insert a shape. So we got axes for our graph, and our litres, volume, is our y-axis, and time is our x-axis. So remember, time, in hours, volume in litres, starting at 0, and then we're going to go up to 3 hours. How do we know to go up to 3 hours? Well, we can do a quick table of values if you wish. So we have time, we have volume as 0, 1, 2, 3. If our time is at 0, then our volume is going to be at 0, because it's not filling at any rate. At 1 hour, we said it was going to be 2,000 litres. At 2 hours, it's filling at a rate of 2,000 litres per hour. Well, that's going to be 2 times 2,000. It'll be 4,000. And so this method here, 2 times 2,000, well, this is our T, and this is our rate of change. And our rate of change is actually our gradient. Do you remember up here, we said the gradient of the graph equals the rate of change. So if we were to swap this around, our volume is equal to our gradient multiplied by time, which is actually in the form of y equals mx. So the volume in the last one of 3 is equal to 2,000. Sorry, I done that wrong. Our volume, don't know why that's there, is equal to 2,000 litres times 3 hours. So the volume after 3 hours is 6,000 litres. Now I know we could have taken that from the question, because that's what it says in the question, at 3 hours, 6,000 litres. But there's your working. There's your rule. Your rule is y equals mx. So it's volume equals 2,000 times your time in hours. So now we have our 4 data points. We're going to put them in. Space them out nice and even. We've got plenty of room here. So we've got 0. And we have our axes values there. So at 0 hours, it has 0 volume. At 1 hour, it has 2,000 litres. At 2 hours, it has 4,000 litres. And at 3,000, it has 6,000 litres. So we have our rate of change. We have our line. We're able to put our graph like that. Okay, and there is B done. Question C says, find the gradient of your graph. Well, the gradient of the graph is very self-explanatory. We found it here. We found it here. It's 2,000. So for I, M equals 2,000. If you needed more proof, you could do rise over run. So you could look at any data point. Let's choose this data point. For this data point to get to the next one, it increases 2,000, goes from 2,000 to 4,000 across 1 hour. So that is 2,000 over 1, which is 2,000. Okay, and if you've forgotten how that works, M equals the rise of the coordinate over the run of the coordinate. Question 2, the rule for V. The rule for V we did here. Y equals mx, and then we substitute in our new values. So instead of y, we're looking at the volume. Instead of m, we're looking at 2,000. Instead of x, we have time in hours. V equals 2,000 t. That's our rule for V. Question D says, then use that rule to find the volume after 1.5 hours. So we substitute. The volume is going to be equal to 2,000 times 1.5. 2,000 times 1.5 is 3,000. And you could use your graph to double check that. At 1.5 hours is going to be in line with 3,000 litres. Part 2 of D says the time to fill 5,000 litres. So this time we have 5,000 litres equals 2,000 times time. When you get time by itself, the time variable of t, so we're going to divide both sides by 2,000. They'll cancel. We have t, 2 goes into 5 because they can be simplified. 2.5 times. So 2.5 hours is your answer. And again, you can double check that by going to your graph, looking at 5,000 litres, work across, and then down, and you're at 2.5 hours. So that is the gradient and direct proportion. As your y values increase, your x values increase at the same rate, and then you are able to find it out. Your rate of change is equal to your gradient. That's a big one. Once you have your rate of change, you have your gradient.